Today we solve for x. And there are 5 types of problems we see in Chapter 4 where we solve for x. Okay, there are pretty much 5 types of problems, and we're going to go over all of them today. But the good news is 2 of them we've already seen. We have already seen this type of problem, where either the bases match already, where you're trying to solve for x, or we have also seen problems where you can make the bases match. So we have also seen problems like this. So the bases match, or we can make the bases match. That was the first time to solve for x problem. The first time to solve for x problem we saw in this unit that was kind of new to us. When we were given an x to solve for up in the exponent, and either the bases already matched for us, or by doing a little manipulation with the bases, we can make the bases match. Does that look familiar to everyone that we did that type of problem? That was the first type, and we'll work on a couple of those later. I just want to kind of do a little rundown of what we're going to be doing today. The second type we saw was where we had a single logarithm equals a number. And for a problem like this, we would rewrite in exponential form. In other words, we would get rid of the logarithm by rewriting as an exponential. We would get rid of the logarithm by rewriting as an exponential. And the type of problem that we maybe saw with this would be something that looked like this. Where did I put that problem? Sorry. That would be what we'd see like that. We'd see a problem that looked like this, with the x mixed into a logarithm, and we had to rewrite it in exponential form. However, what we learned last time in our last class was this only works if it is a single logarithm. So we learned how to condense if we had multiple logarithms. So we learned how to condense if we had multiple logarithms. So if instead of that problem up there, they gave me something like this, before I could solve for x, before I could rewrite this in exponential form, I had to rewrite the left-hand side by condensing it into a single logarithm. So we learned the product rule last time, and the product rule told us that if you have log base b of m plus log base b of n, you could rewrite that as log base b of m times n. That was the product rule. And what that would allow us to do is to rewrite this as log base 4 of 7 times x equals 3. And then we know that the base is the base. So whatever the base in the logarithm is going to be the base in our exponential. And the logarithm equals the exponent. And when I say the logarithm equals the exponent, I think I'm going to confuse some people with this because someone was asking me about this. What I mean is that number over there will be your exponent. The logarithm is equal to the thing that's the exponent. So that's our exponent. So to rewrite that in exponential form, what would I write? What to the what equals what?
4 to the power of 3 equals 7x.
Good. 4 to the third equals 7x. That was perfect. And you might not get your favorite answer, but you don't need a calculator for it, because what you're going to get is 4 to the third is 64. You divide both sides by 7, and yeah, you'll get 64 over 7, which might not be our favorite answer, but it is a valid answer to the problem. And we're done. And then just as a throwback, what happens if they throw this one at us? What was that? 8 to the 2x plus 1 equals 16 to the 3x minus 2. If they throw that one at us, we remember how to solve this one, but it's a little bit tricky. What we have to do is we have to break down both those bases into a smaller base. So it is usually better to turn larger bases into smaller bases. And the question is, can you rewrite 8 and 16 as the same base to two different numbers?
Yeah.
What base would that be?
2.
2 works, yes. So what happens is we say, how do we write 8 as 2 to a power? And how do we write 16 as 2 to a power? Well, how do you write 8 as 2 to a power? 2 to the third, so that's going to be 2 to the third. And 16 is going to be 2 to the fourth. And then how do people mess up this next step? What do they do wrong in this next step? They forget to distribute. Yeah. But we need to remember that that distributes and that distributes. So what we end up is we end up with 2, 6x plus 3, and 2, 12x minus, oops, forgot my x. 12x minus 8. And once the bases match, we had a property that said, if your bases match, then the powers match. That actually works both ways. So then we say 6x plus 3 equals 12x minus 8. And then you just got to make sure you don't botch the last little bit of algebra here by messing up a negative sign. It's easy to do because we get so excited when we get this far that sometimes we make a mistake on the last couple steps here. But this would be negative 6 equals negative 11, or x equals 11/6. Okay, did I get that right? What do you think? I'm just troubled because I'm looking at my notes here. And I'm wondering if I did it wrong because I got a different answer when I did it before on my own. People don't need to hear this. Yep, that's the correct answer. Okay. So class, why do I show you these things? To remind you that we basically had two different ways to solve for x already. And I know this is a long page of notes, but the two ways we kind of already know are the bases match, or you can make the bases match. That's one way. And the other way was if you had a single logarithm equals a number, you rewrite it in exponential form. But if it's not a single logarithm equals a number, we learned rules to combine logarithms so we can have a single logarithm. All right. So let's go ahead and review how to condense. Because having that single logarithm is important. Can we condense that down to a single logarithm, everyone? Even though there's a minus sign, not a plus sign, because what rule do we use if there's a minus sign? Not the product rule, but what was the other one called? It was called the quotient rule. And the quotient rule told us that if you have the logarithm of something minus same base logarithm of something, that equals this. The logarithm of the one with the positive logarithm over the one with the negative logarithm. So this right here can be rewritten as ln of x plus 2 over 7, like that. Done. What's the point of that? We will see problems today where before we can work with them, we need to make sure we just have a single logarithm. That's why we need to be able to do this. That's why we need to be able to do this. We might see a problem like this today, where there's x's running around everywhere. But we can't do very much if we have multiple logarithms. So there's got to be a way to turn that into just one logarithm. And can we turn that into one logarithm? The plus sign in the middle says we can use the product rule and rewrite this as the log base 2 of x plus 4 times x minus 3. And it turns out that once you're within a logarithm, you can do any math you might normally be able to do. So x plus 4 times x minus 3, that can be FOILed, everyone. It's still inside a logarithm, but you can still multiply that out and get this. And then there's somewhere after you combine them using either the product rule or the quotient rule. This one was the product rule. This one was the quotient rule. You can do some simplifying. For instance, here's one that used to trip people up. I remember doing this problem a long time ago. People getting confused by it. You see, we can combine that using the quotient rule, everyone. And I know it's a quotient rule because there's a minus sign in the middle. And what I do is I rewrite this as log of x squared minus 9 over x minus 3. Does anyone in here know how to factor x squared minus 9? The difference of squares. How do you factor x squared minus 9? Brilliant. So if that's x plus 3, x minus 3, does everyone see the simplification we can do? We can turn this into just the log of x plus 3. We can cancel out those x minus 3s and make this the log of x plus 3. So condensing is important. Because when we solve for x in an equation with logarithms, we can't have more than one logarithm on either side of the equation. We can't have multiple logarithms on the same side of the equation. And so we need to condense them to turn many logarithms into one logarithm. I might have told you last time, in fact I'm sure I did, that expanding in this class isn't as important in this class as condensing is. Expanding is something you need to know how to do. It's part of the curriculum for the course. But if you're looking for the application of it, the condensing is a lot more important for us. All right. I'll tell you what else makes today tricky. Solving for x in chapter 4 is tricky because in some problems, logarithms don't ever come up. There are some problems where we never even see a logarithm. An example of that would be like one of our problems where the bases match. We never have to even use logarithms in that problem. We just strip away the bases and just set the powers equal to each other. In some problems, we do whatever we can to get rid of the logarithms. In some problems, our primary goal is to get rid of the logarithms. Something like that. We just want to get rid of that logarithm. We want it out of there, so we rewrite an exponential form. But there are some problems that we solve for x by bringing in logarithms. And that's hard, everyone. There are some problems that we need to use logarithms even though they didn't start with logarithms. And that makes it tricky to know what to do. And that's why we devote an entire day to this lecture, because these solving for x problems are so varied that we need to make sure we practice all the possible tricks that we need to know in order to solve for them. Now, you've seen something like this before, because in the past, you have done solving for x problems where you squared both sides, and in this class, we completed the square, don't worry, we're not doing that today, by square rooting both sides. So sometimes you do one thing and sometimes you do the opposite thing. It just depends on what type of equation you have. And that's what we need to be ready for today, everyone. So you're going to see some problems today where I'm going to be saying, let's get rid of the logarithms. And you're going to be seeing other problems today where I say, let's bring in logarithms to help us solve this. And that could mess with anyone's head. If m equals n and mn are both positive, if we have two things that are equal and they're both positive, then it is the case that they're still equal with or without having logarithms there, as long as they're the same base logarithm. This is a big deal, everyone. What this means for us at the moment, everyone, is if we have two things that are equal to each other, we can take a logarithm of both sides. We have two things that are equal and positive. We can take logarithms of both, and they are still equal. In other words, this goes back in time to one of the first things you learned in algebra class, and that was if you do it to one side, do it to the other side. If you add 3 to one side, add 3 to the other side. If you subtract 6 from one side, subtract 6 from the other side. Now we have a new one. And the new one is this. If you take the logarithm of one side, take the logarithm of the same base of the other. If you take the logarithm of one side, take the logarithm of the same base of the other. That is a valid thing to do now. All right. Let me show you why that might be helpful. Someone tells me to solve that for x. It is difficult to solve for x if it is in the power. I want it out of the power. So I take the logarithm base 10 or base e of both sides. Everyone, why would I take a logarithm base 10 or a base e? Why would I pick between those two? Just, why would I say those are two good logarithms to use? Not the same answer necessarily, but what can they do? Well, actually, we will get the same answer either way. That's not what I'm thinking. Why specifically those two? Why would we not take a base 2 or a base 7?
They're easier to use.
They're easier to use because they're the ones you can do on your calculator. So everyone, here's the thing. If these two things are equal to each other, I can take the logarithm of both sides. And I said, the reason I'm doing that is because I want the x out of the power. How does that get the x out of the power? Who remembers from last time how that would get the x out of the power?
Power rule?
Yeah, the power rule. The power rule from last class told us that if you have a logarithm of something to a power, then you can bring that power down in front. It's okay if you didn't remember that. It's early in the morning to be doing math, but does that sound familiar to people from last time? That power can come down? So what's the point, everyone? Well, if that power can come down, we can get this. Oops. Now, someone do me a favor. On your calculator, make sure you use base 10. Use the L and G, not the LN button. Someone on your calculator tell me what the ln of 2 is. Everyone get out their calculator that's got one and do the ln of 2.
0.301.
I'm sorry?
301.
0.301. Is anyone getting anything different than that? You're all getting the same thing? Okay. Do the log of 7 for me, please.
0.845.
0.845. Does anyone get anything different than that? You're all getting the same thing. You know why you're all getting the same thing? Because log of 2 and log of 7 are just numbers. They're horrible, nasty decimals, but they're just numbers. What we have here, everyone, is we have a number equals x times another number. If we have a number equals x times another number, how do you solve that for x? What do? you divide by that number in front of the x, or with the x. Does everyone agree with that? You would finish this up by dividing by 2. Why? Because it's just a number. Is log 2 a number, everyone? Is log 7 a number? So if we want x by itself, what do we divide both sides by? Log 7. You divide both sides by the log of 7. And then in your calculator, you punch in log 2 divided by log 7. We'll go 4 decimal places on this one. Zero point 3562. That's it, everyone. Of course, the first example takes the longest. Why would we introduce logarithms into a problem when it doesn't have logarithms? We introduce logarithms to get x's down from the exponent. We use ln or log because then we can finish on a calculator. That's why we use ln or log, because then I can finish the problem on a calculator, because most calculators can only do base 10 and base 8. So this one we did base 10, and we were able to get an answer at the end. So why would we introduce logarithms? To get x's down from the powers. That's why you do it. That's why you do it, everyone. Okay. This idea of taking a logarithm of both sides is why we have the change of base formula. This idea of taking a logarithm of both sides is why we have the change of base formula. Let me remind you what the change of base formula is. The change of base formula tells us that if we're trying to do a logarithm of some other base besides base 10 or base e, which we can do on our calculator, then we can rewrite using any base we want. I can rewrite with a base 10, or I can rewrite with a base of e, or I can actually rewrite with any base I want. I just pick base 10 or base e in case I need to use a calculator to finish the problem. This was the change of base formula from last time. That's not what I want. You might remember from last class that I told you just to accept that the change of base formula works, and I would show you why it works next class. This is why it works, everyone. Why does this work? All right. I know this is 5 because 2 to the 5th equals 32. But I will use this to show how change of base works. You will not need to reproduce this explanation on the exam if you just want to watch this and not feverishly try to write it down. You do not need to reproduce this on the exam. This demo is not on your exam. But I will ask for your help doing it right now. Okay, everyone. What I'm going to do is I'm going to show how this log base 2 of 32 turns into the change of base formula. So I'll need your little help, everyone. First one I want to do is I want to rewrite that in exponential form. Can someone help me with that? How would I rewrite that in exponential form? 2 to the what?
To the x.
Good. I rewrite as 2 to the x equals 32. Now here's the thing, everyone. I can take the logarithm of both sides, and it can be any base I want. So here's what I'm allowed to do, everyone. I can either do ln on both sides, or I could do log on both sides, or it turns out I could actually do any base I want on both sides. And regardless of what base I do, I can bring that x down using the power rule. The x can come down using the power rule. So this would be x ln of 2 equals ln of 32, x log 2 equals log of 32, or x log base b of 2 equals log base b of 32. Then, to get x by itself, I would divide everything by the logarithm that's with x. So in other words, I would get x equals ln of 32 over ln of 2, x equals log of 32 over 2, or over log of 2. Got excited, everyone. Over log of 2, or x equals log base b of 32 over log base b of 2. If you go back to the beginning of the problem, x was equal to log base 2 of 32. So therefore, since x equals log base 2 of 32, we have that log base 2 of 32 is equal to ln of 32 over 2. It's also equal to log of 32 over log of 2. It's also equal to log base b of 32 over log base b of 2. So the fact that we can take a logarithm of both sides is the reason we have the change of base formula. You do need to know the change of base formula. I'm not going to ask you to do this on the test, don't worry. But that is why it works. That is why it works. Okay. All right. We may take ln or log of both sides of an equation. We do this to get x down from the power. We may have x's in powers on both sides, or an x in the power on one side. We may take the ln and the log of both sides of an equation. The reason we would do this is to get an x down from the power. However, in some problems we encounter, there may be an x in the power on both sides, and in some problems we encounter there may be an x in the power on only one side. Let me demonstrate. some problems, we might have an x in the power on one side. In some problems, we might have an x in the power on both sides. Everyone with me? The goal is still the same. Solve for x. In both cases, we want to get that x down from the power. The way you get an x down from the power is the power rule. And when you use the power rule is when you have a log or a natural log on both sides. Actually, a log of any base, but we always use the 2 our calculator can do. It 100% on this problem does not make a difference if you do the ln of both sides or the log of both sides. If you do a base 10 or a base e, it really does not matter. I'll do ln this time. And why would we make the problem worse looking by putting logarithms in it? For the one reason that we want to get that x down from the power. That's why you do it. That's how we have to do it, get it down. Because on this left one here, on this first one, I'll just finish this one first. On this one here, what is our next step? Bring the x down. Use the power rule. The x comes down. And now once it's down, what do I do to both sides of the equation? Divide by what?
By 3.
Yeah, you got to be careful here, everyone. You don't divide by ln. You don't divide by 3. You divide by ln of 3. Don't break up the logarithm from its number. You can't do that. You divide both sides by ln of 3. And I made up this problem just now, which I usually don't do, but I did today. So I'm going to punch this.
1.464.
I heard you. Let me just do mine also. What'd you have for me?
1.4649.
Oh, this is interesting. 6497351. This is interesting, everyone. Let's take a moment here. Teachable moment, everyone. How do I round that to 4 decimal places?
465.
You're right, but then we need to put a 0 on it also. So this is something that people sometimes forget. I know some of you know this perfectly because you're used to rounding, but in case you forgot this, you know, if we're going to 4 decimal places, you go out to this 9, and you look at this 7, you're like, that means I'm supposed to go up. And then some people freak out and they say, wait a minute, I forgot what to do. If you're trying to make 9 go up, what do you do? So remember, this is the case where you move over one place, that 4 actually goes into a 5, and that becomes a 0 right there. And if you remember, that's great, but a lot of people do forget that. Okay. This one right here is trickier. This is a tricky problem. In fact, it's so tricky, I'm going to give myself some more room to do it. No, we can squeeze it in here. I'll squeeze it in. I'll be fine. All right, class. I took the natural log of both sides. Why did I do that? So I could do what with the powers? Bring them down. Now look at this, everyone. I'm about to make a mistake. Does anyone know what my mistake is? That power needs to be in parentheses when it comes down. It's an easy thing to forget. That's why we do these problems in class. So you don't have to wonder about that later on your own. When that power comes down, it needs to be in parentheses. How can we say that in your notes? Let's say this. Powers with multiple terms must be in parentheses when they come down. You're not going to like this problem, because it's going to get a little bit worse before it gets better, everyone. I have to distribute that ln of 3. ln of 3 is just a number. So I end up with x ln 3 plus ln 3. Now, you might remember me screaming last time that you cannot distribute a logarithm. I am not distributing a logarithm, I'm distributing a number, because that isn't just an ln I'm distributing, it's an ln of 3. That's a number. So, I am distributing a number, ln 3, not a, I'll just say this, not just plain old ln. I'm not distributing ln because you can't do that, but you can distribute ln of 3 because that's just a number. What am I trying to do here? I forget what I'm even trying to do in this problem. I'm trying to solve for what?
X.
X. Let's get both the x's on the same side of the equation. What good does it do to get both x's on the same side of the equation? Watch this. You factor out x. You factor out x. And now, much to some people's hatred, we divide both sides by ln of 5 minus ln of 3. And after we finish this problem, I'll tell you something about this problem that might make you feel a little bit better. It is my opinion that that is the hardest type of problem we're going to see in this section. They're not going to get harder than that one. So don't freak out that we did that one before break and say, are they just going to get worse? No, they actually don't. Steve thinks problems with x in the power on both sides where you can't make the bases match are the hardest problems in 4.5. That's my opinion. I think that's the hardest type of problem we're going to do today. We're going to do another one like that later, but I think that's the hardest type we'll see. So that being said, everyone, the name of the game today is solving for x, and we will continue solving for x after a break. I will see you all back. There are three types of problems where you solve for x with x starting in the exponent. The first kind we saw a few days ago, it's when you have the bases match or you can make the bases match. That one does not require any logarithms at all. That one's pretty cool. The second one is x is in the power on only one side of the equation. And the third type is x is in the power on both sides and the bases can't match. And those, I think, are the hardest ones. Let's take a look at examples 2 and 3 again before we move on. Now, if you only have an x in the power on one side of the equation, this is important. You must isolate the base and power before you take the logarithm of both sides. Here is an awful looking problem that turns out is not actually that bad, and I'm going to guide you through it. It looks terrible, I know that, that's why I'm doing it for you in class, so you can see this isn't that bad. What you will notice is the x we are trying to solve for, and you can just assume that the instructions today are always solve for x. The x we're trying to solve for is on a base of 1.25, and it's all mixed in with the equation. What we have to do before we can get that base down by using the power rule, by taking the logarithm of both sides, is we have to get it all by itself. It's not all by itself because it's getting multiplied by 2 and we're adding 1 to it. Does everyone see that? So let's get it alone. So I'm going to start by subtracting 1 from both sides. And I'm going to show every little step here just so you're all very clear on what happens. And I'm going to divide both sides by 2. In that case, I find it actually easier to use the decimal 7.5. You must isolate the base and the power before you take the logarithm of both sides. Look at that left side of the equation. The only thing on the left side of the equation now is the base and its power. Does everyone see that? The base and the power are all alone. So the question is this, everyone. The question is this. Do I take the log base 10 of both sides, or do I take the natural log, which is a base e logarithm of both sides? Which one do I do? Which one? Yep, either one is going to give you the correct answer. You can do either one of these. They are both equally correct. It is entirely up to you which one you want to do because they will give you the same answer when you're done. Either way, once you take that logarithm of both sides, the whole point of doing that was so you could bring the x down in front. You actually don't need those parentheses, so I won't bother to write them on this one. And we are still one step away before we reach for the calculator. What do we do on both of them before we reach for the calculator? Divide by the log of 1.25 or the ln of 1.25, whichever one you're doing. Now, whether or not you do this using the ln button on your calculator or the log button on your calculator, you will get the exact same answer. I'm not trying to say that log of 7.5 is the same as ln of 7.5. What I am trying to say is this whole thing over here is the same as this whole thing over here. You do this division and you will get your answer. We're going to go ahead and do 4 decimal places on this. 9 point... I hope I did it right. Are people getting 9 point something?
Yeah.
Okay, good. 9 point, what do you got for me?
0296.
Well done. We'll assume we're both right. Yes. And if some of you did that with ln and some of you did that with log, it won't make a difference. You'll get the exact same answer. One of the biggest mistakes I see people make on a problem like this is once they get it down to this point right here, 1.25x equals 7.5, they know they have to get that x down. They know they have to take a logarithm of both sides, but they get so excited, they do this. Because they don't think that they need to do it on both sides because they only needed to get the power down the left, so they accidentally don't take it to both sides. So I see this all the time where they forget the logarithm on the other side. It's a very common error on these problems. Because you know you need it on the left-hand side to get the x down, and then you just forget to do it on the right-hand side. So this problem that looked like it was going to be a disaster really wasn't the worst thing ever, I don't think. It's a doable problem. But this one is very tricky. And what makes this one so tricky and don't get too discouraged, but I'm pretty sure in the build understanding homework for 4.5, problem number 2 is like this. So they hit you with one of these pretty much right off the bat, but don't get too discouraged. But I'm pretty sure it was just the second problem they get you with one like this. And as I said, I think this is the trickiest kind of problem that we're going to see in this section. I think it's the trickiest type of problem. Some people think this one doesn't look as bad from the beginning because they don't need to isolate anything. They just jump right in with their logarithm. But the problem is, as soon as you do that, and you bring down your powers with the parentheses, it looks like the type of problem that makes you want to give up. You're like, that's terrible. I don't want to do that. Look at that. That's a disaster. But don't forget the mission. ln of 5 is just a number, so you can distribute a number. ln of 5 is a number, and you can distribute a number. So remember, ln of 5 can distribute. ln can't. It's a big difference between distributing a number and distributing a mathematical operation, which you can't do. And I don't like these either, because it's so easy to make a mistake. What am I trying to do? What's the mission? Solve for x. Solve for x. I'm going to add 3 ln 3 to both sides. I'm going to subtract x ln 5 from both sides. And if you do that, you will get ln 5 plus 3 ln 3 equals 2x ln 3 minus x ln 5. So what do? We get all x's on one side. Then we factor out x. Keep your cool, everyone. We're almost there. We're almost there. Then we divide both sides by this. And we will get x equals 2, I'm sorry, we will not. That goes on the bottom. We will get ln 5 plus 3 ln 3 over 2 ln 3 minus ln 5. Gross. If you're going to put that in your calculator to finish up this problem, what you will have to do on some problems, you need to make sure that you wrap both the numerator and the denominator in parentheses. Otherwise, it's not going to work on your calculator. And I got 8 point something if you want to try that and see what you get. Everyone, the answer is 8.3453. Now, if you are having trouble with your calculator, by all means, please come talk to me for help, talk to a friend that has the same type of calculator, or talk to Rachel for help on that. Because any one of us would be happy to help you learn how to use your calculator. All right, let's leave that one alone. Let's not do another one of those today, because they're hard. And I'll just remind you of this. When we take the logarithm of both sides, we use base 10 or base e, so we can finish on our calculator. It does not matter if you use ln or log. But if the equation is already using base 10 or base e, you should match the base. I'll tell you what that means, everyone, don't worry. It really does not matter mathematically when you take a logarithm of both sides if you use the log base e, the natural log, or the log base 10, the common logarithm. It does not make a difference. You will get the correct answer either way. However, if they are already using one of those two bases in the problem, it is easier to use the base that they are already using. Let me show you what I mean. Let's say someone asks us to solve this for x. And let's say we are a student that is all about base 10 all the time. We only ever use base 10. We don't even like base c. So we decide to use base 10. So we take the log base 10 of both sides. We are not wrong. We drop the 2x down in front. That was the whole reason of taking the logarithm of both sides, so we could get the x down from the power. The x is not by itself because it has a 2 over here and it has a log base e over here. Two things we must divide by, and we can divide by them both at the same time. We divide both sides by 2 log e. And that gives us that x is equal to log of 7 over 2 log e. Plugging e into your calculator is a pain in the neck, because on most calculators, to plug e into the calculator, you got to do e to the first power on your calculator. So on most calculators, what you'd have to do to finish this problem is you would do the log of 7 divided by 2 times the log of e to the first power. That's how you'd have to finish it up, because most calculators will prompt you to say you must put a power on e if you're going to use e. And since we want just e, not e to a power, we got to write e to the first. This is going to be 0.9729. And I'll tell you, everyone, there's nothing mathematically wrong with the way I solved this problem. There's nothing mathematically wrong with the way I solved this problem. This is a correct answer. But it looks pretty bad. It looks like long and it looks like it was hard. So here's what I tell you. When you take the logarithm of both sides, we use base 10 or base e so we can finish on our calculator. It does not matter if you use ln or log. But if the equation is already using base 10 or base e, you should match the base. What base is this problem already using? E. Now watch this. If I put an ln on both sides, this is fantastic, everyone, because we learned a rule in class that said, I think this was last week, well, it was definitely last week, I think it was last Monday. We learned a rule that said, if you have a logarithm and an exponential and the bases match exactly, they simplify each other away. So if you have log base b of b to a power, it just simplifies to that power. This is one of the very last things we learned, I think, a week ago. So everyone, do ln and e have the same base? Yes. So that entire side of the equation simplifies to 2x equals ln of 7. Divide both sides by 2. Which one of these would you rather plug into your calculator? Log of 7 over 2 log e, or natural log of 7 over 2? I think the second one's easier. Try it on your calculator. I bet you get the same answer I got here. Do natural log of 7, divide it by 2. I bet you get the same answer I got over here. It is not wrong to always use base 10 if you want to. But you will find it easier if the problem is already using base 10 or base e to use the same base they are using. Everyone see how that one looks easier than the other one? And it is. If you match the base, you can save yourself some trouble. Must use the power rule if your logarithm has a different base than your exponential. But if the bases match, you may simplify. It's a simple way of spelling simplify. You may simplify to just the power. You must use the power rule if your logarithm has a different base than your exponential. However, if your logarithm and the base are the same, then you can just simplify to the power. For instance, what base is already in play in this problem? Base 10. So it would be silly, not wrong, but silly to use a natural logarithm on this one because base 10 is already in play. So if someone tells me to solve this for x, I put an log on both sides of the equation, a log base 10. Now on the left side of that equation, we have a logarithm base 10, and we have an exponent with a base of 10. If the bases match, 10 and 10, you may simplify to just the power. This side simplifies to just 2x plus 3. That is a lot easier than if you had to bring the power down in front. Someone tell me how to solve that for x. What do I need to do to get x by itself? 2 steps. Subtract 3 and divide by 2. Subtract 3, divide by 2. So on your calculator, you do the log of 984. You're going to get a really bad decimal on your screen, 2 point something. You're going to subtract 3 from that. It's going to become negative. That's okay. Then you're going to divide that by 2. Class, are we getting that? Negative 0.0035 roughly? If you're not getting that, let me know. Maybe I made a mistake. I did these ahead of time. But it doesn't mean I didn't mess up.
I get negative 3.
Do the log of 984 in parentheses, subtract 3 from that, and then divide by 2. Is anyone? Okay, everyone. So, this leaves 2 types of solve for x problems. That start with logarithms, and we want to get rid of the logarithms. If you have a single logarithm with x mixed in equals a number, then you rewrite in exponential form. We've done that before. We have done that before. If you have many logarithms, of the same base with x mixed in equals a number, you condense to a single logarithm and rewrite in exponential form. So if you have a single logarithm equals a number, you rewrite in exponential form. If you have many logarithms with the same base equals a single number, then you consolidate or you condense to one logarithm, and then you rewrite in exponential form. We have actually done both of these problems before. That's type 1. Type 2 is you have a single logarithm equals a single logarithm and the bases must match. So if you have a single logarithm equals a single logarithm and the bases must match, you remove the logarithms. You remove the logarithms. What do I mean remove them? I mean if you have log base b of something equals log base b of something, then you just remove the logarithms. Just like that, they're gone. If you have multiple logarithms equals multiple logarithms, bases must match on all, then you condense to a single logarithm on both sides and remove logarithms. If you have multiple logarithms on one side and multiple logarithms on the other side and the bases all match, you consolidate, so you just have a condense, you have a single logarithm on each side, then you remove the logarithms. If you have a mix of numbers and logarithms, get all logarithms on one side and condense. So you have single logarithm equals a number. And then you rewrite in exponential form. Class, if you got numbers and logarithms all mixed up everywhere, get all the logarithms on one side, all the numbers on the other side, get it so you have a single logarithm equals a number, and then rewrite in exponential form. I don't think we're going to see too much of that, just in case. And finally, whenever your equation starts with a logarithm and you solve for x, you need to check your answers. Make sure that putting your x values back in the original equation does not give an invalid base or cause you to take the logarithm of a negative number or 0. Have we seen this warning before? It's going to come into play today. All right, let's do this. Here's an equation that has an x and it has a logarithm. Do we remove the logarithm or do we rewrite an exponential form? What do you think? Take a guess. No one will make fun of you.
Rewrite.
We rewrite it. Why do we rewrite it? Do you know?
It looks a lot easier that way.
Yeah, and the main reason is we can only remove the logarithms, everyone, when you have a logarithm on both sides. And that's the big mistake people make. Is they get so jazzed about this idea of me saying, remove the logarithms, they want to do it all the time. So what happens is, we've got the winner over here, and over here, we have the confused student. Not the loser, just the confused student. The winner takes this thing, and they rewrite it in exponential form, which is 10 to the 9th equals x minus 5. They add a 5 to both sides. And they get the answer is $1,000,000,005. The confused student says, I think Steve said I could just remove a logarithm. And so they just try to get rid of the logarithm, write x minus 5 equals 9, and they get x equals 14. What a difference it makes if you do the problem wrong. If the answer is 1,000,000,005 and you say 14, you're not close. So, this one is wrong because to remove logarithms, we need one on each side. Everyone clear on that? You can only remove the logarithms if you have the logarithms on each side. Otherwise, we're still doing this technique that we already learned of rewriting in exponential form. Okay. So, someone gives me this problem. And it says log of 2x minus log of x minus 3 equals log of 12. Remove logarithms or rewrite in exponential form. Which one? We are going to remove the logarithms, but we can't do it yet. So we will say, we are going to remove the logarithms, but I can't remove logarithms until there is one on each side. That's the problem. So unfortunately, what people do is they remove the logarithms. like that, and that is not correct. You cannot do that. What we do is we remove the logarithms, but we can't remove them until there's one on each side. So, what the winner does on this problem is they rewrite this side over here like that. And how did I do that? What rule did I just use? That is the quotient rule. And now, when you have a single logarithm equals a single logarithm, and they have the same base, you remove. I know it's a lot of details, everyone. That's why we do it in week 11 rather than week 1. If you have a single logarithm equals a single logarithm and they have the same base, you can solve for x just by removing the logarithms. They're gone. You're actually not dividing by logarithm because remember that doesn't make any sense. You just say removing. It's actually more mathematically correct to say you're destroying them than you're dividing. How do I solve this mess for x? What do I do?
Multiply both sides by x minus 3.
Very clever. Multiply both sides by x minus 3 to kill the fraction. Distribute. Get the x's together. Divide. Get an exact decimal. Class, if you start with logarithms, you want to get rid of the logarithms. And there's two ways to do it. Either rewriting an exponential form or removing the logarithms. You just got to make sure you know what to do and when it's okay to do it. That's what makes it tricky, is when can I use the rule? Okay. We doing all right, class? Trying to give you every little step in here so you don't get confused later when you're looking at it or listening to this. The answers were fine on the last few problems. I checked them before class. But now we'll do one where we check the answers together. Oops. You see, that removing the logarithms idea seems so desirable that we want to do it even when we can't do it. This one is not going to be a remove the logarithm problem because this one has a number on one side. We will rewrite an exponential form, but first we will condense left side to one logarithm and then rewrite in exponential form. We condense the left side into a single logarithm. Then we rewrite in exponential form. What is my base? 4. What is my exponent? 2. Four squared is 16. And suddenly, we are back in the world of quadratics. And the way we solve a quadratic is we set it equal to 0 and we solve for x. So unfortunately, we are not done yet. We have some more work to do. Now we did something great. We took something with logarithms in it and we got rid of the logarithms. They're gone. But now we are back in our quadratic section where we have to do a little bit more work. Because this is equal to x squared minus 6x equals 16. So what we must do to solve this problem is move the 16 over to the other side and either factor that or use the quadratic formula or use completing the square. We have to do something to figure out the values of x that make this true. Fortunately, they're probably not going to call upon you, and I certainly wouldn't, in this section, in this unit, unit 3, to complete the square and use the quadratic formula. So we should be able to factor that sucker. Can we factor it? Everyone, when you think of getting 16, what two numbers do you think of multiplying?
8 and 2.
8 and 2. So it's got to be 8 and 2 somehow. And because that's a minus 6, it could be a minus 8 there and a plus 2 there. Which means, what are my two answers here?
X equals 2 and x equals -8.
Try that again.
-2 and 8.
Good. See, you were too sleepy when you were doing that problem. Okay. -2 and 8. The original equation looked like this. Log base 4 of x plus log base 4 of x minus 6 equals 2. That was the original equation. We have done nothing wrong. We have done the math perfectly. And when we did the math perfectly, we got these two answers. But you need to ask yourself, if I plug those answers, one at a time, back into the equation, do I end up doing something I'm not supposed to do? In other words, if I let x equals -2, then this is going to look like this. Is that okay? Can we take the logarithm of a negative number? We cannot. X cannot be -2. If I plug 8 in there, I am not checking every little detail. I'm just making sure that I never take the logarithm of a negative number or 0. If you look at that, is there any point in there where I take the logarithm of a negative number or 0? No, 8 is cool. Once again, everyone is going to get -2 and 8 when they do this problem. Everyone. The students that get it right, or the people that get it right, are the people that reject -2 and keep 8. You have to check your answer. And normally, as you get better at these, you can pretty much just check it in your head. But I wanted to do this one on the board so you could all see what my thought process is. And the thought process was, you can't take a logarithm of 0 or a negative. And that's why we had to get rid of that answer of -2. All right. Class. Well, that looks awful. Supposed to solve that for x. What should I do? At some point in this problem, will I be able to remove the logarithms? Yes, I will be able to remove the logarithms. What must I do before I remove the logarithms? What do I need to do? I'm sorry. Oh. I can't do this. This absolutely is not okay. No, don't do that. What must I do before I remove the logarithms? I need to condense the left-hand side into one logarithm. I have to. Before I remove logarithms, I must condense left side to a single logarithm. It's my only hope. Not to a single logarithm, that doesn't make any sense. To a single logarithm. I must rewrite this side as ln of 5 minus x times negative 3 minus x. That's going to be a pain to FOIL. Equals ln of 3 minus 9x. You really can't do anything if you have multiple logarithms on one side of the equation. So we got to condense it. But once you have one logarithm equals one logarithm, you remove the ln from both sides. And suddenly the logarithms are gone. But you got to condense first. Foiling with all these negative numbers is a pain, so I would not try to FOIL this in your head. I would do it one step at a time. 5 times negative 3 is negative 15. 5 times negative x is negative 5x. Negative x times negative 3 is positive 3x. And negative x times negative x is positive x squared. I didn't try to do anything fancy or do anything in my head. I just FOILed that out. This right here is a quadratic. So we set equal to 0 and factor. We get everything on one side and we factor it. So on this side I have x squared minus 2x minus 15. I will add the 9x and I will subtract the 3 from both sides. So what I did, everyone, was I collected like terms on the left-hand side and rewrote it in the order that I find more comfortable, descending order. Now I'm going to move the 9x and the negative 3 over to the other side. And after much problem, much difficulty, much frustration, I do get a quadratic that I can factor. How do you factor that? Once again, everyone, what do you think of when you think of multiplying two numbers to get 18? What do you usually think of?
2 and 3.
You either think of 6 and 3 or 9 and 2. So this one's going to be 9 and 2. It's going to be plus 9 and minus 2, so I can get that plus 7x in the middle. So I get two answers, everyone. I get negative 9 and 2. When I solve a problem for x and it started with logarithms in it, what must I do? In general, what do I have to do?
Make sure you're not taking the log of a negative number.
Good. So I will check. And what do I check in? The original. The original untouched equation. There's the original, everyone. That's the original. If I put a negative 9 in there, does it work? I see the nods. It does work. It does work because this is going to end up being 14. This is going to end up being 6. And this is going to end up being 84. Those are all positive numbers. That one's okay. -9 works. If I plug a 2 in there, that looks good. Oops. You see this one, but as soon as it fails, it's out. I don't even need to check the last one. It's screwed up already. Everyone see that? It's no good. Why did I do this problem? Because I wanted to show you that it is not always the case that positive numbers work and negative numbers fail. What matters is what they do in the original equation. You cannot just assume that because the number's positive, it's a great answer. And because the number's negative, it's a bad answer. And that is exactly why I did this example, to show us that we need to check in our original equation. So, always check in the original equation before you condensed or did anything else. You must go back to the beginning. So what will happen next time, everyone, is next class we'll do the last details of 4.5 and cover 4.6, which is our application section. But actually, I don't think the application section is that bad. I think we'll be okay. We'll have a good time. Everyone, I'll see you on Thursday. Thank you so much for coming. Have a nice afternoon.